Celine, about this exam, when Tariel asked me about the exam, I thought actually he asked about my exam, all right? Because sometimes I give you exam, right? And just to see your progress, how everything is going. But Mr. Adala's exam, Sasmo exam, I have no idea. You need to ask Mr. Adala. They are the organizers, and I'm not working with them together. I'm just your teacher. I just teach here, okay? So when do they have exam and how is it? How they're organizing? I have no idea, and I'm not involved in that. I only teach you here math.
Okay.
Okay, Salim, because it is in Azerbaijan and here in Baku, and I don't know, they have a kind of education center or company, whatever it is, how they organize, I have no idea. And just we have a contract, and I meet you here and just teach you, prepare, I mean, teach you math and prepare for Sasmo. And about the exam dates and everything detail, I have no idea. Okay, so directly you need to ask Mr. Adalat, or we have another girl here, Miss Aisu. Actually, they are in charge of that organization. Okay. So I really have no idea. Actually, I heard from Mr. Adala that they are going to have some kind of exam by the end of this February. The exact dates and Sasmo also approximately April. About the details, really, I have no idea. Okay,
Okay.
good. So now today we are a little bit late because I finished my previous class a bit late because we had to finish something. So it's all right, no problem. So what who we have here? İlknur, Adilhan, Selin. Adilhan,
Yes.
Adilhan, can you turn on the camera for 2 minutes?
Yes, I did it.
Adilhan, how do you join the class? You just join the class and after that you go to your bed and sleep?
No.
So how do you join the class? Huh?
Like you mean the previous one?
Yeah, the previous one you just joined and you didn't notice that it was different class. Do you know that your classmates are here, İlknur and Selin and
Yes, I know.
Nigar?
Like I didn't saw them, like the names.
Hmm.
And I forgot the time.
Okay, okay, good. Adilhan, did you go to school today?
Oh, tomorrow maybe I will go
Tomorrow. Maybe. What do you mean by maybe?
because of snow. Maybe I will not go.
Is it still snowing?
Yes, little bit.
A little bit. Okay, good. So guys, then let's continue. Selin, İlknur, are you there?
Yes.
Okay. So İlknur, Selin, if you remember, we were solving these questions. We did a few questions. Let's continue. 1 hour is snowed and that's it. Okay, 1 hour, sometimes even 1 hour. Also here, it just rains for a few minutes, but in a few minutes, actually, the water will be your knee high, sometimes really it's a lot. Here, when it rains a lot. Maybe just 20, 30 minutes, but in 20, 30 minutes, it's a lot. Anyway, guys, let's continue them. We did these questions last time we started. Let's finish this, and after that I will see, maybe it will be another paper or continue our topics, one more chapter, and again get back to the Sasma. I will see. Okay, so that is the last question we did last time. And if you remember, find the smallest whole number n for which 108 times n is a multiple of 306. So it should be 10, right? And anyway, today, let's continue from here, 25th of February. All right. Okay. A circle and a quadrilateral. İlknur, can you read the question and let's discuss if you did this?
A circle and a
Tell me the method.
quad.
If you didn't know, let's do it together. Yes, İlknur.
A circle and a quadrilateral are drawn on a flat surface, which is the biggest number of regions that can be formed on the surface. Which is a quadrilateral?
Quadrilateral, it is four-sided figure. Like rectangle, square, rhombus, parallelogram, trapezium, they are all quadrilaterals, right? Four-sided figure.
Yes.
Okay, Stalin, let's actually listen to your guess. What is your brain saying to you now? How many?
What how many? 8.
We draw a circle and the quadrilateral are drawn on a flat surface. What is the biggest number of regions that can be formed on the surface?
I think it's whether 8 or 6. That's my
Let me
guess.
just let me just draw any circle, right? Now the problem is how should I draw my quadrilateral so we will have maximum number of what is it? Regions. You said 8?
8 or 6, I'm not sure.
8 or 6. Adilhan, İlknur, Raul,
No answer.
no answer. Why? Say something. Yeah, we have 5 answers here. How many? 1, 2, 3, 4, 5, 6, 7. Do you think we can make more? Oh, this is triangle, right? It should be
We
quadruple.
can make more.
Huh?
We can make more.
Yeah, actually, I draw triangle, but it should be quadrilateral, right? Because one side should be maybe something like this, and also something like this, and something like this, and maybe something like this. Okay, but not this part. I will delete this. So at the time, how many? 1, 2, 3, 4, 5, 6, 7, 8. But can we make more?
I said 8.
Yes.
How about if I make like this? And I have one idea. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. One, two, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyway, actually, I think we can make more than 8. I think it should be 10. Because now I can make 9, right? Is it 9? Why, Mr. Adilhan, say something. Why are you so quiet? This one is 1, 2, 3, 4, 5,
Yes, there is 9.
6, 7, 8, 9 regions. But do you think we can make more? 10? Can we make it 10?
I think no.
A circle and anyway, I think I'm just trying because if it is 9, it says what is the biggest number of regions? Biggest number of regions that can be formed on the surface, right? Anyway, I think it should be 9, but here it should be 10 because I don't know how can we make 10.
8.
8? But here I can
Yeah.
make 10, Selin, more than 8.
But you said 9, so it can be just 8. That's why. Can we just say that it's 8 so I will be correct?
Hmm. Anyway, I think we need to think about this question, guys. I think because it's 9, if it is, I'm just thinking, can we make it 10 or not? If no answer from you,
No.
why no? Are you tired today? The last try, we will move to the next question. And suppose that this is our circle. The last try, okay. Suppose that's our circle. And let's say the quadrilateral, it can be anything. 1 and okay, 2 and 3 should be from, I should join from here. Still 1, 2, 3, 4, 5, 6, 7, 8. Okay, Selen, let me just choose 8 for now, but let's see. But still, I have a question mark about this. Let's see.
8 is correct.
8 is correct. Are you sure?
Yes. My brain says to me.
Okay. Okay, let's see. If I actually can find 10, then I will let you know. Okay, let's move on to the next question, 15, 16, and after that, after 15, the questions are a little bit harder. Okay, no problem. Selin, read the question and explain to us. What do you understand? How can we solve this?
Okay. 70 cakes are packed in 2 different box sizes. The small box holds 6 cakes and the big box holds 8 cakes. If more than 10 boxes are used and all the boxes are fully packed, how many small boxes are used?
If more than 10 boxes are used and all the boxes are fully packed, how many small boxes are used?
I think 7 or 9.
Because that means that it's 6, right? Here we have 6 times how many small boxes? I don't know. It is n plus 8, right? Times m. So that's equal to 70 cakes. What is the question? How many small boxes are used? To answer this question, right, this n is equal to 70 minus 8 times m over 6. So we have to solve for n. Actually, 2 is a common factor here. 35 minus 4 times m over 3, right? So here, if m equals 131, it's not divisible. If m equals 8, it's 27. So if m is equal to 2, 35 minus 8 is 27. It is 9. So n is equal to 9. N is equal to 9. What is the question? If more than 10 boxes are used and all the boxes are fully packed, how many small boxes are used? We use 9 small boxes.
I said 9 or 7, so that's 9.
Did you say 9?
I said 9 or 7.
9 or 7?
7 or 9, that I said.
But we
So
don't have
that's
such answer, Salen. Your answer is F. It is 7 or 9, right? But we don't have such
yeah.
answer. Okay, good. That's it. Again, we just did a lot of questions like this involving whole numbers. So that's the way we solve this question. All right. Is Nigar here? Nigar, are you here? Nigar. Okay. Raul. Raul, can you read this question? And it's a logical question, I
Yes,
think. Right. Raul, read the question and let's talk about this. As you see here, section B, starting from 16 to 25. Correct answer, 4 marks. Incorrect answer, no answer is 0 answer. This is a little bit harder question. Yes, Raul, can you read the question?
Okay. Jane is at road junction with 4 possible roads to her friend's house, but she didn't know which road to take. So she asked some passerby for direction. First, possibly your friend's house is not on road. Uh, the second, possibly when I didn't want to live near your friend, so I moved from road 2 and road 4. This possibly I have taken road 2 to the beach before, but I have not passed by any house. Fourth, possibly your friend stays on road 3. If only the possibly is telling the truth. Sorry, the truth. On which road does Jane's friend live?
Okay, thank you, Raul. Here, Jane is at the road junction, and here we have a road junction in the middle, right? And he doesn't know, or she doesn't know where to go. This one is road number 1, and road number 2, road number 3, road number 4. Okay, actually, in navigation, actually, they call this exit, right? Exit 1, exit 2, exit 3, exit 4. Anyway, and it says that, but she didn't know which road to take. So she asked some passerby for direction. Passerby means people who are passing by, right? Or just walking by. Okay, first passerby, it says that your friend's house is not on road 1. Okay, it means that maybe actually that he's saying that her friend lives either on road 2 or road 3 or road 4. And second passerby says that I did not want to live near your friend, so I moved from 2 to road 4. So that he is implying that actually her friend is living in road 2, right? It says that I did not want to live near your friend, so I moved from road 2 to road 4. That means that her friend is in road 2. Third passerby, I have taken road 2 to the beach before, but I have not passed by any house. Okay, that means that that's actually saying that not in road 2. Okay, fourth passerby says that your friend stays on road 3. All right. So it says that if only one of the passerby is telling the truth, on which road does Jane's friend live? Adilhan, Raul, Ilknur, Salin, Nigar, what do you think? If you understood the question, the kind of logical question, right? It's saying that if only one of the passerby is telling the truth, that means that if only one is telling the truth, the rest of the passerbys are lying, right? Telling a lie. Celine, what do you think?
I don't know.
Ilknur, any idea?
I'm still thinking.
You are still thinking. I'm also thinking. Let's think together. If only one of the passerby is telling the truth, on which road does Jane's friend live? And suppose that the first guy is telling the truth, okay? So that means it is false, this one is false, this one is false. That means that your friend's house is not on road 1. That means that it may be road 2, road 3, road 4. And this one is telling the false, that I mean not telling the truth. The second one, it says that road 2, so that means that she's not living in road 2. Okay, and not road 2 also lying, that means that he must be living in road 2. They are actually contradicting each other, right? So that means that one of them is telling the truth, so which means that the first guy is not telling the truth. If you look at the second one and the third one, the second and the third, right, And they're just telling two different things. I did not want to live near your friends, so I moved from road 2 to road 4. So that means that his friend was living in road 2. And third one, I have taken road 2 to the beach before, but I have not passed by any house. Okay. So that means that he's saying that her friend is not living in road 2. So that means that if the second passerby is telling the truth, the second one is lying, right? If the second one is telling the truth and second one is, anyway. So actually, I just consider these two cases. Suppose that he is telling the truth. Now I have to show that all others are lying. So if it is on road 2, it's not on road 1. Oh my gosh. Okay. Adilhan Raul, let's just skip this question for a moment. Okay, it's taking time and like Celine, my brain is not saying anything to me. It's a logical question and it's a bit confusing. Let's think for a while about this question, okay? If anybody has idea, and we will get back to this and discuss later because now it's taking time. I want to skip this question for now. All right, next question. Elsie has 20 pence. She divides them into 4 piles so that each pile has a different number of pence. Find the smallest possible number of pence in the biggest pile. So that means that actually altogether 20 pence. I'm sorry, I left my bedroom phone. Okay, Sally, good. 4 piles, and let's say this is the first one, and that is second one, and the third one, and the fourth one, right? And it says that she divides them into 4 piles so that each pile has a different number of pence. Find the smallest possible number of pence in the biggest file. So suppose that this one is the biggest file, right? So it seems actually to be the biggest file, right? And each one has different number of pence. Actually, for the last one to have the maximum number of pence, and other piles must contain smallest number of pence. So starting with 1, I should just put only 1 here. The second one, it should be different from the first one, so it is 2. And also the third one, greater than 2, and the smallest integer, that is 3. 1, 2, 3. What is it? I can put here 1, 2, 3. It is 6. I can put 14, right? Well, what's the question here? Find the smallest possible number of pence in the biggest pile. Find the smallest possible number of pence in the biggest file. Okay, at the time it must be the biggest right here. So if it is biggest, okay, 14. And how about if it is 2, 3, 4, 7, 9, 11, and 3, 4, 5, it is 8, 9, 12, and 4, 5, 6, 11, 15, it is 5. But it cannot be, right? It should be this, what is it? Maximum. So the possible answer is only 8. Raul, did you understand this question?
Yes.
How about the solution? I mean, did you understand why we get 8 here? Because in the question here is saying that we have altogether 20 pens, and I'm just grouping them, right? And I'm just putting them into 4 different, let's say, pencil bags or pencil cases, so that each pile or each pencil bag has a different number of pens, right? So that means that if you just pick any 2 bags, the number of pens in each bag, it must be different. So the question is, find the smallest possible number of pens in the biggest pile. Okay, so the biggest pile means it's the bag that contains the most number of pens. And suppose that in the first bag, if it is 1, the second one, it cannot be equal to 1, right? So it should be 2. Third one should be 3. At the time, the biggest one contains 14 pens. But how about the first one contains 2, and after that it is 3, it should be 4, right? So at the time, it will be 11. How about if the smallest one is 3, and next one should be different from the previous one? It is 4, and it is 5. So at the time, it will be 8, right? So actually, the biggest one, the 8, that means that it cannot contain less than 8 pence. Okay. Okay. So the answer is here, it is 8. All right. Adilhan, read the question.
Anna thinks of 7 different positive integers. None of the integers is a multiple of each other. What is the least possible sum of these 7 integers?
So Anna thinks of 7 different positive integers, right? None of the integers is a multiple of each other. What is the least possible sum of these 7 integers? So actually, what is the least possible sum of these 7 integers? So we have to try to choose the smallest numbers, right? I cannot start with 1 because actually, if you just multiply any number, for example, any number is a multiple of 1. So I should start with 2. Another smallest integer, which is not the multiple of 2, what is it? It is 3. And another integer, which is not multiple of 2 or 3, that is 5, right? Now, if I write here 6, 6 is a multiple of 2 and also a multiple of 3. I cannot write 6 here. So what is the next integer that's not multiple of 2 or 3 or 5? That is 7, right? And also 8 is a multiple of 2. I cannot write here. 9 is a multiple of 3. I cannot write 9 here. And how about 10? It's a multiple of 2. So 10 also cannot be the answer. And 11, right? So how many? 7. Next 12, now it is 13. How many already? Not 14, not 15, so not 16, that is 17. Simply, actually, the first 7 prime numbers, right? So what is the least possible sum of these 7 integers? So these are 2 plus 3, 5, 5 plus 5, 10, 10 plus 7, 17, 28, 41, and 58. So the sum is 58. Ilknur, what do you think? Does it make sense?
Yes, it does.
Do you agree with me?
Yes.
Okay, let's see. Celine, can you read this question and explain to us how do we do that?
Yes, the diagram shows a square, the equilateral triangle, and parts of a regular polygon. How many sides did the latter polygon have? I didn't get it.
Did you understand the question, Celine?
No, I mean somehow yes, but not all. So
It's like, we have a kind of polygon. Maybe it has n sides, but actually, as you see here, I can form a square, right? It says a square, and after that, equilateral triangle, And after that, maybe I can form another square here. I should draw a bit longer. A square. Again, here we have equalated triangle and continue, right? So actually, what should we get here? Before we continue, it says also what it says here, regular polygon, right? And how many sides does the letter polygon have? And if you know, we know that the sum of the interior angles of any polygon is, what is it? It is 180 times n minus 2. Celine, do you know this formula? This is how to find the sum of the interior angles of a polygon, right? Do you know this formula?
No,
No? Are you sure?
no.
The idea is very simple, Celine. Let me just show you one figure and how we are using this formula, and you will get the idea. Okay. How many sides does it have? 1, 2, 3, 4, 5, right? And the sum of the interior angles means these are the interior angles, right? Angle 1, angle 2, angle 3, angle 4, angle 5. And what are we doing here is I'm just multiplying 180 by n minus 2. Why is this so? Because if I just draw diagonals here, that's the first diagonal and that's the second diagonal. And here we have pentagon. How many triangles can I form here? This is the first triangle, that's the second triangle, and the third triangle, right? It has 5 sides. I can form 3 triangles. If it has 6 sides, 4 triangles. 7 sides, 5 triangles. So we know that the sum of the interior angles of a triangle is 180. So that's why to find the sum of these angles, 5 minus 2, it gives us the number of triangles here, and multiplies by 180, it gives us the sum of the interior angles of any polygon. So what do we mean by regular again? Regular means all sides are equal and all interior angles are equal. So that means that since it has n sides, right? And suppose that one angle here, one angle is alpha. So that means that how many angles we are adding? Here we are adding n angles, right? So n times one interior angle, because all angles are equal, because we are talking about regular polygon. So n times alpha gives us the sum of the interior angles of regular polygon. Now from here I can find alpha then. What is one angle actually? One interior angle. The sum of the interior angles and divided by the number of sides of the polygon. It gives us one interior angle. Now from this question, it says that it is a square and equilateral triangle. Square means that what is this angle? It is 90 degrees, right? And how about this angle? Since it is equilateral triangle, it must be 60 degrees. So that means that one interior angle of this polygon, then it is 90 plus 60, that's equal to 150 degrees. Now I know one interior angle of this polygon. So actually just substituting this into the equation, I can find m. So now if you substitute here, what is alpha? 150 degrees. On the right hand side, we have 180 times n minus 2 over m. Now the 0, 0, they cancel each other. Multiply both sides by n. So here we have 15n. And here on the right hand side, expanded 18 times n. 18 times 2 is 36. Take 18 and to the left hand side, 15 times n minus 18 times m is equal to negative 36. 15 minus 18 is minus 3. What is n? Minus 36 over negative 3. That's equal to 12. So that means that the number of the size of this polygon is 12. Okay, Salim. Now did you get it?
Yes.
Good. Okay, then. Let's move to the next question. Nigar, are you there or only your name is here? Nigar,
Yeah, I'm here.
what are you doing, Nigar? Watching the snow?
No,
What are you doing, Nigar? Tell me.
I'm doing the question right now.
Really? Can you read this question 20 and give us some idea how to do it? First, can you read the question?
Okay. Question 20. In the figure below, the ratio of the area of to the
Triangle
area of
ABC.
yeah, the area of triangle ADE to the area of triangle AVG is 7, 8, 15. Given that 1/4 of the area of triangle ADE is shaded, what fraction of the figure is?
Okay, so I think not so easy question, but let's see. In the figure below, first have a look at the figure. The ratio of the area of ABC, okay, we can see ABC, to the area of ADE, okay, to the area of AFG, what is AFG? AFG is 7 to 8 to 15, okay? Given that 1/4 of the area of ADE is shaded, all right? So what fraction of the figure is shaded? Given that 1/4 of the area of ADE is shaded, what fraction of the figure is shaded? Okay, so that means that what fraction of the figure is shaded means we need to find, right, the total area, maybe in terms of the shaded region or something. And after that, we need to divide this. It gives us what fraction of the total figure is shaded. Okay, so what can I do here? So the area of ABC, okay, we can see this ABC, ABC to ADE to AFG is equal to 7 to 8 to 15. Okay, so that means that if this one is, let's say, X, and this one is, let's say, Y, X plus Y, X plus Y to X plus Y to A, what is it? ADE. ADE, it is 18, right? So it is Y, okay. ABC, it is X plus Y, okay. And this one is XY, let's say this part is Z, and AFG, and let's say it is W. So that means that ABC is X plus Y, and the ADE, it is Y plus Z, AFG, Y plus Z plus W. Okay, so that means that X plus Y to Y plus Z to Y plus Z plus W is 7 to 8 to 15. Okay. So given that 1/4 of the area of ADE is shaded 1/4. Okay. So that means that 1/4 of Y plus Z is equal to Y. All right. And what fraction of the figure is shaded? So that means that we need to find this. Y over X plus Y plus Z plus W. So we have to find this. Okay, Adilhan, Rahul, Ilknur, Nigar, did you understand how did I label this? Okay, and it's just my
Yes.
idea. I don't know in different way how can we do that, because usually in this kind of regions, as I say here, we have 4 different regions, and I just label them with some letters X, Y, Z, W, and after that it's given here area of ABC. What is ABC? X plus Y. And area of ADE, that is Y plus Z. Area of AFG, that is Y plus Z plus W, and that ratio is given X plus Y to Y plus Z to Y plus Z to plus W. That's equal to 7 to 8 to 15. Okay, so since it is a ratio, all right, I can just take it as also like because here Y and this are the ratios, right? And I can just take it as, what is it? X plus Y is equal to 7. Okay, okay, just 7. And Y plus Z is equal to 8. And Y plus Z plus W is equal to 15, right? Now from here, Y plus Z, it is 8. Now what is W then? W is equal to 7, right? So now I know W. W is equal to 7. And Y plus Z also I know in terms of Y. Now I need to find X. Uh, okay. So Y plus Z equals 8. And do we know Y? Okay, Y plus Z. All right, good. All right, let's continue. Now we know what is W. Now from this relation, again, what is Y plus Z? Let me just change my color so that it's just a solution here. So from here, Y plus Z is equal to 4 times Y, right? Now 4 times Y, what is Y plus Z is equal to 8. So which means that that's equal to 8. Now from here, Y is equal to 2, right? If Y is equal to 2, Z must be equal to 6, right? So I know Y, I know Z, I know W. What is left? X left. If Y is equal to 2, then X should be equal to 5, right? Because of this equation. Now, if I substitute here, what is Y? Y equals 2 over X. X equals 5. Y. Y is equal to 2. Z. Z is equal to 6. And W equals 7, which is equal to 2 over 7, 14, 20. So that's equal to 1 over 10. So dot, dot, dot, the answer is 1 over 10. So 1/10 of the figure is shaded. Now, if you're telling, you may wonder, Mr. Qasim, how do you know that X plus Y and Y plus Z and Y plus Z plus W is equal to 7, 8, and 15 respectively? Okay, here we are talking about the ratio, all right? But even without knowing this, suppose that it's not. Actual ratio means this X plus Y equals 7P and Y plus Z is equal to 8P, okay? And this one is equal to 15P. And if you even if you just substitute here, everything will be in terms of P, and here Y something P, and X, Y, Z, W something P. Just take this P out. P will be the common denominator. Just cancel them out. That's why it does not change anything, because here we are just talking about the ratio, not the exact value of that area. All right. Another question. We have just a few minutes left, guys. Let's do this together. Ilknur, can you read the question and let's do it together? And let's try to do this together. Sometimes some questions are really
Yes, the
tricky.
diagram shows a rectangle being divided into three smaller rectangles and a square. If the perimeter of the unshaded rectangle is 42 centimeter and the area of the square is 42 centimeter, find the total area of the shaded rectangles.
One mosquito fly around here, I couldn't catch it. Okay, good. Thank you, Ilknur. The diagram shows a rectangle being divided into 3 smaller rectangles and a square. So that means that that's at the top right, this one is square. Okay. If the perimeter of the unshaded region is 42 centimeters, and the area of the square is 49 centimeters squared. What the area of the square is 49. So that means that this one is 7, that's also 7, and this sides are equal, right? Okay. If the perimeter of the unshaded rectangle is 42, so that means that, do we know the side? I don't know. Let's say it is, this one is 7, right? And let's say this one is x, also this one is x. And this one is y, and this one is 7. This is also x, this one is y. And it says that if the perimeter of the unshaded rectangle is 42, what is it? Perimeter unshaded region is 2 times x plus y, that is equal to 42, which means that x plus y is equal to 21. And the area of the square is 49, that is 777. Find the total area of the shaded rectangles. So what is the total area of the shaded rectangles? Let's say the total area of the shaded rectangles is, let's say this one is part A and this one is part B. So that is part A plus part B. What is part A? That's just equal to 7 times y, right? Width times length. Plus, our part B is equal to 7 times x, which is equal to 7 times x plus y, and which is equal to 7 times, what is x plus y? That's equal to 21. So that's equal to 21. That's equal to 147 cm squared. So the area, the total, what is it? The total area of the shaded rectangles is 147 centimeters squared. Okay, Nigar, it's an easy question, I think. Okay, not so hard. Let's move to the next question. Adilhan, can you read this question? It's about being politeness, I think. Polite numbers are blah, blah, blah.
Polite numbers are numbers that can be expressed as the sum of two or more consecutive positive integers. 5 equals 2 plus 3, and 9 equals 2 plus 3 plus 4 equals 4 plus 5. Find all the polite numbers that can be expressed as the sum of two consecutive positive integers.
Okay. So polite numbers are numbers that can be expressed as a sum of two or more, right? Two or more consecutive positive integers. Okay, that is 5 equals 2 plus 3, or 9 equals 2 plus 3 plus 4, that's equal to 4 plus 5. Okay, find all the polite numbers that can be expressed as the sum of two consecutive positive integers. Find all the polite numbers that can be expressed as the sum of two consecutive positive integers.
Maybe 5 plus 5 will be 10.
Shall say again?
Maybe 5 plus 5, which will equal to 10.
Why 5 plus 5? Why?
Maybe because there are two positive integers.
But it's saying two consecutive, right? Two consecutive positive integers. It's like, for example, 1 plus 2, or 2 plus 3, or 3 plus 4, 4 plus 5.
But then 5 plus 6.
Basically, find all the polite numbers that can be expressed as a sum of two consecutive positive integers. Polite numbers are numbers that can be expressed as a sum of two or more consecutive positive integers. What I'm saying is we have a lot. Why? Is something missing here? Find all the polite numbers that can be expressed. What is a polite number? It's a number that can be expressed as a sum of two or more consecutive positive integers. 5, 2 plus 3. 9, 2 plus 3 plus 4, or 4 plus 5. Lesson finished. Okay. Yes, Salim, lesson finished. Okay, but what can we do? All right, let's just skip also this question for now because something is missing. Let me just check the original question again. And we have a lot, but why they are asking this question? And also question 16, if you remember, it's a logic question. Also think about this. Uh, how many rectangles are there in a 5 by 5 square grid? I think we already did this. One more time we will do this. 24, the last digits, and 25. Okay, 3 questions left. Guys, that's your homework. Let's say try to do this. Okay, if you can do this, write on nice on a piece of paper and you can share with us in WhatsApp. Let me see. Ilknur, did I share this paper with you? This Sasmo 2005 S1.
I
Yes,
don't remember. I don't think.
Okay,
I
if not,
think
again, I
you
will
did.
just share with you once again. Okay, at least you can see what questions are done, what questions are not completed yet. Okay, and when you have time, have a look. All right, and try to solve this. If you have any idea, different ideas, share with me. Okay, also this will be experience for you. Guys, thank you very much. If you have exam, Selin, tomorrow, okay, I wish you good luck. If possible, Selin, Nigar, Ilknur, Adilhan, if possible, try to save the questions, okay? Selin, you know how to do that, right? Screenshot and save it. Screenshot and save it. Also, we can discuss together in the class time, okay? If you can. Because it will be online,
Maybe
right?
with clear.
Tomorrow's exam. Will it be online?
Yes, we don't need to join something, but we need to go by the link, and then we can just do the test and then submit whenever we want. I mean, we can just join it just once, not twice, not 3 times. So whenever we are ready, we can join and then do and then submit, and that's it.
Yeah, I mean, Selin, if possible, when the question appears on the screen, you can screenshot and save it, right? I mean, if the
Yes.
questions are nice questions, we can just and discuss also in the class time. Okay. Yeah, in case if you can do that, if you cannot, it's fine. But now, if it's online, you can screenshot everything and just keep it, save it in your laptop. Okay. Anyway, guys, thank you very much. All right. See you next Monday. Have a nice weekend. I wish you good luck in your exam. Okay. Bye bye.
Bye. Have a nice day.
Bye bye. Thank you.